Hi, everyone. Welcome to the podcast. I'm here today with Jobst Landgrebe and Barry Smith. They're the authors of Why Machines Will Never Rule the World, Artificial Intelligence Without Fear. Before we get into it, can each of you give a short biography, just your background and how you came to write this book?
Barry, you start?
Yep. Okay, I'll start. So I'm a philosopher by training. I worked for quite a while applying philosophical ideas in other sciences, including biology and medicine. And in this connection, I came into contact with Jobst, who was working as a high-level consultant to pharma companies and the like. And we decided that we both had very similar views about the way, I don't want to use the word scam, but the way in which the health industry is very often infected by over-ambitious views as to the capabilities of computers. And this led slowly but surely to our working together on this book.
And
Okay.
Jobst, what's your background?
Yeah, thank you. So I'm by training a physician, biochemist, and mathematician. I also studied a bit of philosophy. And I received my my PhD in biochemistry in '98. And after that, I worked quite a long time in academia before I then went into consulting, strategy consulting. And that's where I met Barry. I've done AI research and applications since 1998. I'm an entrepreneur. I have a small company that does AI consulting, but also some AI software engineering. And I wanted to write the book because my customers were all the time asking, why are you doing this? Why are you doing that? And I always said it because it doesn't work. And then they didn't believe me. And then finally I thought that Barry and I could write a paper about it, which we did. And then after the paper, we wrote another paper. And then we thought, let's do a book. And so that's about the topic. And that's how we came to write the book. And that was my motive as an entrepreneur, but I also have a motive, of course, as a scientist, because I think that it was high time that somebody, describes the limitations of AI properly, because there's so much hype and it's so nonsensical that I thought we need to really properly analyze it once.
Okay. Yeah. So the book caught my eye because the title is not subtle. Why Machines Will Never Rule the World. So it's not talking about next month or next year or current technology. It's saying that basically there's something impossible. There's some impossibility here that people are promising. So it's a heavy book, a lot of ideas, a lot of mathematical equations. If you could just sort of summarize what's wrong with sort of the conventional view that there will be a superintelligence and it'll be able to do what it wants.
So first of all, I wouldn't say it's a conventional view, but it's a view taken by people who are influential in the public space, but don't know really so well what they're talking about. So people saying this, most of them are engineers, but not mathematicians or physicists. So, and there's just one mathematician, one physicist who is quite known, who says it. What's his name again? The one who wrote the book about time, Barry?
Hawking?
Stephen Hawking. He also says it, but he had a tendency to a bit of yellow press tendency and popularization tendency. Plus, I think he never looked at the problem really carefully. But the mathematicians and physicists and also many computer scientists who look at it properly, they recognize that it can't be done. And we also mention many of them in the book, in the first part of the book. Now, that said, the core reason why we think that it will never be possible is that because we believe that, I think we know that our ability to model systems using mathematics, which is a foundation of AI, is very limited. So there's only a small part of reality that we can really model mathematically in an adequate way so that it works. And that's the reason, because the reality of intelligence is so super complex that our mathematical models cannot capture it. That's the core argument of the book.
And maybe I can add a few things. So first of all, if you try and understand how the brain works, then you very, very reach a limit to what you can represent mathematically. And if you look at textbooks of neurology, there are very few equations in those textbooks. So in order to build a device which would mimic the operations of the brain in performing intelligent behavior, you would need to have an entirely new kind of mathematics. And also you would need to have huge amounts of imaging data at resolutions which would be orders of magnitude finer than what we can achieve physically. And so for all of those reasons, the complexity of intelligent behavior is beyond the reach of mathematics. Now, if it's beyond the reach of mathematics, then it's beyond the reach of mechanical or electronic devices, because they need mathematics to work.
Mm-hmm. Yeah. Okay, and that makes sense. So the idea is that basically mathematical modeling. I think some people maybe have this view that it's some kind of magic. It can basically do anything you said, and you just need more computing power, or you need more effort, or need more scientific, right? But you're basically saying, I mean, you have emphasize some ideas like the turbulence and these things that we cannot model at all. And what the way you put it in the book is, it's like we have this idea that math sort of explains the world, but explains very little. I can explain gravity, right? Because it's the one force dominates everything. But then you add a little bit of complexity, and you simply can't explain what's going on. If you can't explain what's going on, you probably can't invent something that requires a complex system. Is that basically the argument?
Yeah, that's one important aspect. So you were now basically discussing about the interactions between matter and also force overlay. These are two properties of complex systems that can't be modeled well. And so they have many forces which are overlaid to create the effect, And so this is very hard to model mathematically. That's one important aspect. Others are that complex systems like human beings, but also animals, which also are intelligent, have evolutionary properties, so that they evolve all the time and that they can add new dimensions to themselves. Give you an example from bacteria. So if a bacterium can acquire a toxin, which can totally change its ability to invade a host and to replicate in the host much more efficiently, like Clostridium tetani, which causes tetanus disease, and it has this toxin which makes it super efficient as to infect and kill hosts, and so and it has acquired this during evolution. And mathematical models, they can't cope with new dimensions because they are always using a fixed set of dimensions, a kind of you can imagine it like a Cartesian coordinate system, right? And you need to, when you create a mathematical model, you need first to define the Cartesian coordinate system, quote unquote, I simplify a bit, that you're going to use. And so they can't cope with evolution. And there are many other properties they can't cope with.
Maybe I can draw attention to the usage of the word intelligence. So there are clearly AI systems that can behave in ways which, in a sense, are more intelligent than the ways humans behave. So playing Go or playing chess, for instance, are good examples there. They can move very quickly and they can perform calculations very quickly. And this gives the impression that they're intelligent. But this is what we call narrow intelligence, which means it's along one single dimension or along a very small number of dimensions, precisely where mathematics can still work. But organisms, including humans, have general intelligence, which means that we can have multiple dimensions, we can add new dimensions, we can create new combinations of dimensions on the fly. And that's where the big difference comes between what is achievable by artificial means and what is only achievable by something like an organism.
Yeah. I think there's one part of your book you say something like, if you changed a single rule in Go, the program would be useless, right?
Yes.
It would not be able to. It would just be nothing, and so you'd have to start from scratch.
That's the closed world problem, right? So for AI to be really successful, you need an ergodic system or a closed world where everything is at the end repetitive, and where the dimensions are closed, and the small world also. And the big open world AI can't cope with because it doesn't think; it just replicates patterns that it has, so to speak, encountered. And that's also the case for GPT-3, which is the foundation of ChatGPT, which is now the latest rage in AI discussions, but it's also just a repetitive algorithm.
So we're recording this in mid-January 2023. So ChatGPT came out about a month ago, and people are impressed with it. I mean, it can you could say write a play about X and Y going to the store and getting into a fight and then making up. I saw it could write some basic code. I saw that it could get humor. Somebody asked it write a joke about like why the DNA was sad or something, and write a joke about DNA, and it said there was a helix and it didn't have a connection. It was something like that. It got like a pun, right? It understood it, so it could do jokes, it could do plays, it can answer basic questions. It can write an essay. So why is this not just sort of a matter of degrees from scaling up to the general intelligence?
Because this algorithm is a sequential model. So all it does is basically it learns chains of symbols, right? So it's fed with trillions of sentences and texts, and all these texts contains, of course, from the perspective of the algorithm, these are just chains of symbols which are encoded as long chains of zeros and ones. And what the system does is that it basically acquires a model of the distribution of the symbols. And then when you give it an incomplete, every input it receives is inside the system regarded as an incomplete input which needs to be completed. And then it completes it in a way that corresponds to the distribution of the symbols that it has encountered in the training. And this is because it is so huge. It's very amazing what it can do. So it can complete many sequences in a very seemingly meaningful way. But in reality, it doesn't understand at all what it's doing. And therefore, it is everything what it does is like dotted with errors and wrong statements all the time. It doesn't create any reliable output, right?
So there are different ways in which you can measure the power of something like an AI. One way would be if it can start a war against human beings, for instance, or do something equally horrible in some other dimension. Another way is whether it can provide something of benefit to human beings, which means monetary benefit primarily. And so the question would be, can an AI replace a human comedian in telling jokes in a late night comedy show? And I think that the joke idea that you referred to is not an indication that they will take over from comedians. They will not be financially or beneficially relevant in the comedian sphere, nor in the essay writing sphere, I would predict. They can write essays, but can they write essays better than the people who are paid to write essays now? Probably not. Can they write plays which are better than Tom Stoppard or somebody? Probably not. So they will not, under any of those dimensions, be replacing human effort for gain, financial gain. Now, what else can they do? Can they do science? No, it's horrible what they do when they try and do science. They make up references. They make up people. So they say, oh, this idea was invented by so-and-so, and they've just made up a name out of the blue. And that's a characteristic of these deep neural network type approaches to AI, that they have artifacts which generate strangeness, and you can never track down where the strangeness comes from. But they do generate strangeness, and it's very hard to understand or eliminate. And the strangeness is everywhere as soon as you start poking it in specific dimensions. So they made up a whole career for me. For instance, according to one conversation I had with ChatGPT, I did my PhD in London. That's because there is another philosopher called Barry Smith who did his PhD in London, but he doesn't have any of the other qualities of me. So it's like that. Whenever you poke it, you get weakness, and that weakness is going to mean that you can never use it for a mission critical purpose. You can use it for writing short essays. You can use it for writing essays in school, but you can't use it for any critical purpose because it's full of made up falsehoods.
Yeah, there was a second part of the question, which is very interesting, which we haven't answered yet, and where he was asked, and can't we imagine extrapolated, it's getting better and better. And it has been becoming better and better over the last 10 years, right? So the neural networks for sequence generation of symbols have been around. I've been observing them since 2011, I think, actively. So they've been around for a while, or 2012, I don't remember exactly, but for a while. And they have, of course, improved. But But their basic problem hasn't improved. Their basic problem is that they are purely reproductive and can only produce what they have, the distributions they've seen before. Now, the human intelligence means, and now this is taken right from our book, the definition of human intelligence is the ability to solve problems rapidly or instantaneously without prior exercise that are completely novel. That's the fundamental definition of intelligence we use. It's from Stern and Scheler. It's from the 1920s, but it's still a very good definition. And this is what they can't do. They can only apply situations that they have learned once. And that's also for car driving and for all the other, circumstances under which you can think of using AI. That's why AI, we don't say AI can't be used. It's a huge potential. It's applied mathematics, can be used in many ways, but not to replace the ability of human beings, which I just described.
Yeah.
Intelligent.
But the problem with this, are most humans intelligent under that definition? So, I could ask ChatGPT to, write an essay about, the cause of World War I, and it can do it, and it could probably get a C or something for a college course. And so, what is the sort of what is the sort of limiting principle here that will make you have to think there's something very, very sort of qualitatively different between, say, a C paper and an academic publication in the field, right? Is that the claim? Because it's gone, people would say, I think people would have said before, this is intelligence. To get a C in a college course requires some intelligence, right? It's not huge intelligence.
Okay, but I see where you're going. So, but intelligence means that now the next thing you ask the machine is to tell you to solve a new problem that hasn't encountered before. So it can write an article about World War I because there's a lot of material about World War I in the World Wide Web, which it replicates. But if you ask it, for example, how does the Blitz, Barry?
The Blitzkrieg? Lightning.
No, lightning. How does a lightning work, right? How does it work? Then it will replicate what is said in physics textbook, but it probably will not say systematically what our limits to understanding lightning are, where they come from, why we can't model lightning properly, and so on. So it will not give you the real explanation is to describe the limitations of this and why the limitations are there and so on, and what are research endeavors that could help a bit on this and so on. This it won't be able to do. So it's just replicating things. That's not intelligence. It's not solving new problems. Whereas many human beings who can't write an essay about World War I, and I would say that out of the 8 billion inhabitants of the earth, most can't write an essay about World War I. I agree with you, but most can solve an unexpected problem occurring in their lives. And they have to do it every day. Even if they're not really consciously thinking about it, they do it. Yeah. And so this is what is the difference. And so this machine is acting in a very, very narrow context. And there it is reproducing knowledge. And that's with some mistakes. It's still impressive, but it's not intelligent. It's just reproduction.
Mm. Okay. So what I'm hearing is sort of, maybe we're sort of getting a little bit confused by imagining intelligence is just on a spectrum, a straight line. And so the computers, they can do multiplication, they can run a regression, in a second. And maybe they can write essays, and maybe this really is like a, I don't want to say a lower form of intelligence, but a different kind of intelligence. They can beat humans now. At writing a World War I essay, which is pretty interesting. They could beat, a good portion of humanity. But then, they can't maybe, call a doctor and reschedule an appointment and, whatever, something very, maybe they can, maybe that's not a good example, but, get a, I think one of the examples that I've read somewhere, maybe it was in your book, dealing with a beggar on the street. Right. This is a sort of complex problem that no artificial intelligence has applied for. So maybe, maybe people would have thought they could be cops before they could write World War I essays. But maybe we were just wrong, and that was just because we misunderstood sort of the nature of machines and the nature of humans. Does that sound right?
So let's think about what is involved when a human writes an essay about World War I. They don't just want to, well, I'm not talking now about a typical schoolboy. I'm talking about somebody, as historian, let's say, or somebody who's interested in government and good government wants to avoid World War III. So you're writing your essay on World War I. Why did World War I happen? And you have in your mind then a desire to contribute in a number of different ways to the future of the planet. You want to avoid another war. You want to get things right. In other words, you want something. You want a lot of things, and you want your essay to be true. You want it to be correct so that your desires won't be thwarted by people who point out that you don't even understand World War I. None of those things is present in the computer. And I know that because I've been playing with ChatGPT to try and get it to want not to make mistakes. And it doesn't understand. It doesn't understand what it is to want not to make mistakes. And that's something that every human being, in one way or another, is capable of. We're all capable of acts of will. And so human intelligence is general, not merely in that it's involving multiple dimensions, but also in that it's involving wanting to get things right or wanting to achieve something. It may be that you want to achieve something bad, but humans are always wanting. And this is one of the reasons why humans are so good at conversation, because everyone who enters into a conversation has a will to achieve something through that conversation. They want to impress somebody, they want to cheat somebody, and both sides have wants which keep the conversation alive and make it take twists and turns which the other side couldn't anticipate. And that's one of the reasons why computers still can't pass the Turing test, because to pass the Turing test, you have to be really good at conversation. And they've been trying to get really good at conversation for 50 years. And even today, if you call your bank's computer will, in almost every case, not be satisfying. You will not be satisfied with the encounter. You will want to speak to a human being because human beings have this kind of intelligence which we all share and which machines never will have, we say.
Yeah. So so before ChatGPT, there was DALL-E came out, and this to me is, I know a little bit about how the language models work. I don't know much about how this sort of this art works. Can you talk about sort of the difference of that, how impressive that is, and what the difference between the language models and the the DALL-E, which creates pictures for you? What's the difference of how they work, and sort of what are the implications for all these ideas?
So DALL-E and others, they are adversarial networks. So they work by, you have two networks. One creates a content and the other one rates the content. And by running multiple cycles of these two networks, you get an optimized picture. And these pictures are, of course, not art. I mean, there are pictures. Obviously, you can look at them, you can recognize something, but they are not art in the sense of human art. And that has to do with what art is, and what is the true nature of art. And the true nature of art: authenticity, originality, and formal perfection. Right. And this is one definition of what the core of art is. And you don't have authenticity in a machine which just performs an algorithm. So this dimension is gone. It can be formally quite perfect what it does. So this criterion is fulfilled. But originality, I wouldn't say either, because the machine just combines patterns that it has observed in the corpora it was used to train it. So I would say it's definitely not art what it creates, though it is an output that you can look at. In Germany, we call it Kunsthandwerk. Barry, can you translate this?
Craft.
Yeah, craftsmanship. It is, in a way, but it's not art.
But it seems like it seems like that definition sort of just it makes it by definition a machine can't do art. You say it's authenticity, right? You're looking underneath the hood and you're looking at the process. Well, it's going to be a different process because it's a machine. It's not a human, right? So that sort of doesn't that sort of just that definition by definition make it no matter what they would do, you would say it's not art.
If you look at the history of art and look what we see as great art in the history of art, then these are like a Goya or Velázquez, right? These pictures burst with authenticity. You can see the person of the artist in the pictures. That's the same when you read Dostoevsky or other great literary artists. A lot of their person is expressed. It's what Thucydides, a great Greek historian, called the anthroponym, which is what makes a human being make a human being. And in the works of art of these great artists, or you listen to chamber music by Brahms, you can hear it. This is the authenticity I'm talking about. Maybe and yes, of course, machine can't be authentic. And you can say, oh, that's a self-fulfilling prophecy, but it's actually not a joke. It is really what makes art desirable and wonderful, is this expression of the person in the art. And that's what.
So I'd like to add a tweak to what Jobst just said. So it turns out that if you play around with DALL-E, then there's a lot of human effort which is involved to create what you might think of as more valuable pictures. So if you just put the phrase in that you want to have represented, you typically get a very flat cartoon that no one would find admirable in any way. So if there is, in fact, still a human artist in the loop. And I can well imagine that in the future, human artists will be able to create great works of art by tuning DALL-E in ways which other human artists have not managed to do. And so you would bring in the dimension of originality. But this is an aspect of AI tools which is typically underestimated. Namely, you get good results from these AI tools only if you have good human beings who are feeding the right kinds of instructions to the AI tools and deciding what the right kind of data is to feed into the training set for the AI tools, and so on and so on.
Maybe we should come to a very fundamental point that we didn't make yet, which is very important for Richard to understand. So when you look at this bottle of water, there's some water left in it. The molecules in this bottle of water have an ergodic distribution. So when you take a portion of the water out of the bottle somewhere, you get a representative sample. Even if I shake the bottle, I wait a bit, now it's ergodic again. You saw there were bubbles coming up. It was non-ergodic for a very short time. Now it's ergodic again. And so what the human mind creates, and also what animal minds create or animal brains create, is a process that is non-ergodic. And so when you sample from it, that's what you do when you train AI systems. You sample output from non-ergodic systems. And so then you can always train them to produce something, but it will only catch the ergodic part. But the non-ergodic part, where is made in a way that you can never draw a sample that is repeated. Another example is if you look at the waves coming to the ocean where you live, to the Pacific, each wave that ever reached the Pacific coast has a different shape. At the micro level, no shape is like the other. So if you now make photographs of the waves and teach a machine to generate waves, if you made many, many photos, you get waves that look from a bigger perspective like real waves. But if you analyze them at the micro level, they will not be like real waves, because they will have an ergodic pattern. And this is a real important point, that you can't teach a machine non-ergodic behavior. And at the end, the behavior of natural driven systems creates non-ergodic distributions. And that's the key. That's a mathematical core of why the neural networks can't really become intelligent. They can be trained to do special tasks really well, and it's admirable. And we don't want to. I make a living out of it. I make a living out of helping my customers use the system. So I think it's great. It's a great form of applied mathematics, but you have to distinguish between useful applied mathematics and how can I say this, secularized eschatology, where you suddenly think that the AI can replace the subject of your faith that you have in religion, and that's what we're observing in our society, is that more and more people, see AI like they might see God or something like this. I mean, even the book by Harari is called Homo Deus, because he expects humans to create things that God only can create.
So one of the things that people who believe in the singularity say is, they have this thing called the substrate independent hypothesis. So the idea is that, okay, humans are basically an intelligence or a personality or whatever. It's just process of information, and we can, eventually upload that into, a computer or something. And, you can have you can be, you can live forever, because we'll take the information that's in your mind and put it on software. And it seems like you are just, you call this dualism. You call this sort of a Cartesian kind of dualism that just science has gotten rid of, but still these people who believe in AI, the singularity, sort of rely on it. So can you talk about that a little bit? I found that idea fascinating.
So shall I start?
Yes.
Yeah, so first of all, there are all kinds of technical problems that you would have to solve in order to upload the content of your mind into the cloud, which is what they have in mind. You need to have imaging of your mind, again, which would be of these very high orders of resolution, which we simply can't achieve. But more importantly, we'd have to kill you first, because we can make images of your brain actually behaving intelligently only if we can get an imaging system which would look at what's going on at the deep molecular level. And we can't do that without killing you. Now, maybe we can solve those practical problems in the future, but then we would still have the mathematical problem that the behavior of the molecules in your brain, which brings about your intelligent behavior, the behavior which is unique to you, just as every single wave on the beach anywhere on the Pacific is different from every other one. So your intelligence, which is specific to you, is different from every other intelligence of every other person. And so we can't even use mathematical laws in order to generalize from a few imaging data sets so that we can get some kind of generic intelligence, because every human intelligence is going to be different. So for all of these reasons and other reasons, which we document in the book, you can't upload the content of your mind into the cloud. And if anyone do that for you, you should say, well, if they go first, then you will follow.
A deeper answer to your question is that we also bring forward the deeper answer in the book, is that the view that many proponents of theory of the mind bring forward, that the mind is just a machine, is wrong. So we don't think the mind is a machine. Why do we say the mind is not a machine? Because a machine is a logic system that works, that doesn't have the properties of a complex system. So a machine, the only property of a complex system that a machine usually have is drivenness, because you need energy to run the machine. Like the car needs energy, or my computer needs energy. However, for the functioning of the machine, its consumption of energy is irrelevant unless it breaks. So if my computer overheats because the cooling doesn't work anymore, then the energy consumption becomes relevant, but otherwise not. And so machines are characterized that they are simple or logic systems, and the brain is not a logic system. That's why it's wrong to see the brain as a machine. And that's even true for the brain of very primitive organisms like a fruit fly, which have just very few neurons, but they still can behave in a very rudimentary form intelligently, because they can adapt to new situations they haven't encountered, they can find solutions and so on. Not very well, and they are very limited, but still they have a rudimentary form of insect intelligence, and let alone mammals who are very intelligent, have a social life, can even rudimentarily teach other non-genetically inherited patterns to their children and so on. And so this intelligence is not the result of a machine, but it's a result of a living, animate, complex system. And so therefore, philosophically, the analogy to make an analogy of the brain with a machine is Cartesian, as you mentioned, and it's fundamentally wrong, I believe. And Barry thinks so as well, I think.
Yeah. So, the question is, do we need... one question is, do we need... You make a good case that we can't understand, the human brain, and we can't understand complex systems. But we can do a lot without understanding. So if you look at, for example, we've domesticated animals, right? We've done selective breeding. People didn't know about genetics or how any of it works very recently. We still don't know exact genes involved, but we can drive evolution in one way or the other. Could something be done similarly with human intelligence? We could have very limited understanding, or artificial intelligence, or to match human intelligence or surpass it. We could have a limited understanding, but we can sort of tinker with machines and design models and sort of build on them and eventually get something that's very impressive. Is that one possible route to the singularity?
So we have, Barry, that's the evolution argument. Do you want to start on this?
Yes, sure. So the general evolution argument to the effect that you could simulate evolution in the machine in the same way that you simulate the expertise of a Go player, for instance, by having the machine mimic the thousands and thousands of generations which evolution has involved for organisms, but they mimic that inside the computer. That's how they imagine they're going to teach cars to be driverless. They're going to have cars drive around without drivers, mimicking driver behavior over and over again. Eventually, they will have enough data to be able to train a neural net to behave like a human being. Similarly, if we simulate evolution in the computer, then if we start with a very stupid AI-like starting point, and over again, we kill off the more stupid products of each phase of evolution, we will eventually evolve a truly intelligent AI-like entity. Now, the problem is that we wouldn't know how to, or one problem is that we wouldn't know how to program the computer to do all of that because we don't understand evolution. And most of the data that we would need to understand evolution, we will never have because it's all in the past. And the reason for that is because evolution is a way more complicated problem than intelligence. So there's so much more involved in evolution that we do not understand. To try and mimic it in the computer would be really, really difficult. So difficult as to be impossible.
There's another, but you made another important argument, Richard. That's the argument of breeding animals, right? And so, what's the name of this? I always forget him. Who is also Singularity proponent, the British philosopher Barry. I can look him up. The one who should go back to
Chalmers? No,
yeah, not Chalmers. The other one. But Chalmers also makes the argument. So what they're saying is that you can just breed more intelligent humans and breed so long until you get super intelligent humans.
You mean Bostrom?
Yes, that's Nick Bostrom. Thank you. And so this is so, and he also thinks of actively manipulating the genome. So if you want to actively manipulate the genome, you need to understand how intelligence comes about so that you can change the genes that generate intelligence. Now we know that body height is encoded by 80,000 genetic loci. So it's a pangenomic inheritance pattern, and intelligence even more. But we even don't know how many, most of the genome contributes somehow to intelligence. So we don't know at all. So it's so complicated. So many, not even only the coding genes, but also non-coding genetic parts of the genetic code contribute to intelligence, so that we don't know what to manipulate. So genetic engineering is out, and breeding is naive because it believes that it supposes that you can linearly increase complex trait via breeding. But how breeding works is that you can isolate traits pretty well, or some traits. And if you look at all the variants of dogs that exist have been created by breeding, you can see this, or tulips, but you can't, so to speak, by breeding change the fundamental pattern of the properties. And so it's just a lack of knowledge of biology and genetics that brings people like Bostrom to think that we can maybe breed higher intelligence.
Yeah.
And so
we'll go back to the biology and the genetic enhancement. I wanted to follow up on what Barry said. I wasn't thinking in terms of no, it's okay. I wasn't thinking of terms of simulating within the machine, but just a market system where you have companies, right? They're all trying to do different things. Some of them, do better than others, and a very long time scale. You have creative destruction. You have some, doing better than others, and eventually you get something that looks like, a super intelligence. Why can't that be just sort of the tinkering and sort of the evolutionary process there?
Yeah, so I think that goes back to our basic argument about complex systems versus logic systems. So let's look at a really, I think it's really impressive. Jobst is much more critical in this respect, but I think that Google Translate is really impressive. It's a really useful tool. It's not a good tool for doing good translations, but it's a useful tool for getting the gist of a piece of text. How does Google Translate works? Well, it takes a language, let's say the German language, and it fixates it. It fixes it at a time, and it uses that fixed body of German to train a neural net. And then it does the same thing for English. It fixes English. And it uses then the two bodies, the fixated bodies of linguistic data, translated into sequences of zeros and ones to create a mapping so that you can take a piece of German today and get a piece of English as output. Now, all of that is done by converting what are incredibly complex systems, namely the entirety of the German language, with the X million people speaking it, making up new ways of speaking it every single day, and the entire body of the English language, which is similarly dynamic, they turned both of those dynamic complex systems into simple systems. And the result is really useful. And in 10 years, it will be even more useful. But it's useful always only along this one narrow track, namely getting translation. And it's never going to be able to tell jokes or prevent war or take over the universe. It's always this one narrow track. And so the kind of general evolution that you're praying for or fearing or speculating about won't happen, because the evolution is always along one narrow track. And that's the same with ChatGPT. It's going to be always along this one narrow track.
Maybe to add on this with regard to your market argument, it's a very good argument, yeah, because markets are creative, right? And it is the history of the world, and especially the place where markets were the most productive, which is, this. How is this shape from northwestern Europe to south to northern Italy, right? Where all this evolution happened in the Renaissance and in the modern times. So the humans created this evolution, and they created amazing new things. And if you subdivide them into technical entities and non-technical created entities, the technical entities they created from that time until today. Let's say from Leonardo's drawings of imaginary planes until today's ISS, right? These are all simple logic systems exploiting laws of physics that were discovered and systematically building the machines. But they are all simple systems. They are amazing. They're super impressive. Think of the Large Hadron Collider and so on. But they are all simple systems, logic systems. They're not complex systems. Unless they get out of control, like Chernobyl. So when you have a simple system that gets out of control, it becomes a complex system. So this is what the market does. But the output of the market with regard to technology is not about creating complex systems. The systems then can be used in a complex way. So if you think the car itself is of course not a complex system, it's a simple system. But if you have a person driving a car, it becomes a complex system because the human being adds the complexity. And also many other non-technical products which the markets have created are of course complex, like a novel by Dostoevsky or a piece of music by Brahms. But that's not that's because humans created it, and so spontaneously it's just not visible. We don't know how to transform a simple system into a complex system without adding animal or human activity. When we add animal or human activity, we can transform any logic system into a complex system. But without adding it, we don't know. And that's, I think, the key point. And so to get complexity, a natural system has to be involved.
Yeah. So can you so you touched on something that I read in the book, and I just want to make sure I'm clear on. Can you talk about the role of driveness and intentions in your idea of what separates animate life and inanimate life?
Do you want to start, Barry?
So you do this one.
Okay, so drivenness means that there's a flow of energy through a system. And so in nature, many systems are driven. Yeah, so if you think of, for example, if you go skiing and the wind is blowing through the snow, you see turbulence, very beautiful patterns of that's a driven system because there's kinetic energy, and this kinetic energy is dissipated. Turbulence is created. It's very beautiful. If I pour water into this glass from this bottle, I create turbulence, and this turbulence is also complex, and it's also drivenness. It's inanimate drivenness. And then animate drivenness means that there's an organism which can create energy on its own and spend the energy for survival and reproduction, right? So that's why a virus and a prion are not animate systems, because they can't create energy on their own. But so that's the animate system. It can create energy on its own and spend it. And it does it with a certain built-in goal, which is survival and reproduction, which is what life is about. And this is both types of drivenness lead to, it seems, unsurmountable obstacles in mathematical modeling. And so we can't model turbulence at all. We have no way to know it, and it seems unmodelable. And that's turbulence is an example of drivenness happening in inanimate systems. And the drivenness in animate systems is much, much stronger because, of course, we have turbulence all the time in our body. Every time the heart pumps in the aorta, we have a lot of turbulence, and we can't model it. And it goes through the whole body. There's everywhere phenomena that are like this, for which we have no clue how to model them. We can do very good partial models. We also say this in the book. And these partial models have enabled modern medicine, for example. But we can't have this overarching model that explains it fully. And that's what drivenness is about. Drivenness creates situations that make it impossible to create holistic mathematical models, inanimate and inanimate nature. And that's also why the models that we have of inanimate nature are limited. That's why we can't have realistic climate models, for example.
So when I hear the people who are believers that AI, the superintelligence, one of the things that sort of seems made sense to me, but I don't know how to feel about it now, is the idea that basically there's nothing if we take a materialist worldview, and you say in your book, you said very clearly, you don't think there's any, there's no kind of dualism. There's nothing special about human consciousness that makes it different from the rest of nature. The idea is that basically, there's why would it be that nature produced something that we cannot match? Because in some ways we've surpassed nature in some things, right? We have bullet trains that can travel faster than any animal. In some ways, we're not as good as nature. We can't, go hunt a gazelle or something, make a machine that does that. The cheetah, could go do something like that. Is your idea, is one way to sort of frame it as we underestimate the power of evolution and we overestimate sort of human intelligence? Because maybe, the irony is we are just way overestimating human intelligence to think we can reproduce what evolution did blindly, over billions of years.
Do you want to take this one?
Go ahead.
So there's the tradition in European thinking that has created this kind of hubris. It started with Descartes, and then other French guys reinforced it. And so in France, you have many thinkers who believe that you can Laplace and Lagrange. They all believe that you can model the universe with partial differential equations. They were not invented when Descartes worked, but later on they got invented, and then Lagrange and Laplace believed this. And this is this, and then also not Gustave Le Bon, what's the name? Auguste Comte believed that you can even model societies with partial differential equations and he wanted to create sociology as a branch of mathematics. And so this is a Cartesian illusion of that you can reduce your life to partial differential equations. And it looks compelling at the first glance because these equations seem so powerful, but then you realize very quickly how little you can do with them, how partial they are, because they only model very few variables. And if you have too many variables, you can't use them anymore. And so their modeling capability is very limited. And I think that the whole, thing we are discussing depends on this misunderstanding of the extent of which we can model nature. And it's very, very restricted. And interestingly, all the big physicists, like Richard Feynman, but also what's his name? We quote him, Roger Penrose, and many, many other great physicists. They say they're very aware of the limitations of mathematics, and they are aware because when they create the models, they always have to abstract heavily from real nature. So every physics textbook, every problem that is described in physics starts with, now let's assume this, and this, and let's abstract away this and that, and then assume this. And so they end up with systems that are highly artificial so that the mathematics can be applied. Nancy Cartwright called this physics as a theater, because you have to arrange and direct so much before you can bring the mathematics in. And when you look at the real world, and every physicist knows this, then it's very different. Then very few phenomena can be explained. And that's why the real applications of physics are all in engineering. Because there you can yourself decide on the system and build it according to what you learned from these highly abstracting models. And I think that's very important to acknowledge. And I think that once you know how physics work and how physicists model the real world and how mathematics gets applied and how big the discrepancy between mathematical modeling and the real world is, then you can appreciate how little we can do. And I think that this is very, very hard to understand, because to understand how physics works, lay people can't. They don't understand the mathematics. They don't understand. I mean, although I spent most of my life doing mathematics, when I started to learn physics to write this book a couple of years ago, I was struggling. It's hard to learn. And then I realized, wow, yes, I learned thermodynamics, and then we could write the book because it's using a lot of thermodynamics, right? And this is only possible to see the limitations when you've gone through the way that physicists create their models.
So 12 years ago, I was invited to give a keynote lecture at a big conference on safety in automobile engineering. And it was a conference which was full of people who are already then working on driverless car technology. And I told them that in order my expertise is ontology, which means I try to find ways in which you can merge different kinds of data, make data systems interoperable. And I told them that there are so many dimensions of data involved in car driving that to ensure that you had a safe system for a driverless car would take many years. I estimated 14 years based upon the fact that testing a drug for safety takes about 14 years. And everyone in the room was horrified because they all planned to be out of a job in 5 years, because they thought that there would be driverless cars everywhere within 5 years. That was the estimation which everyone was talking about at that meeting. Now it's 14 years later, and I think we can say that there has been very little advance towards the goal of that meeting, which was safe driverless cars. And that's because people overestimated the power of mathematics, which can describe simple systems, and underestimated the complexity of real nature. And so it's still an open question, the degree to which we will have driverless cars. But Jobst and I are convinced that there will never be driverless cars which can drive in open environments, which means environments which can include any kind of phenomenon, whether human or animal or weather or earthquakes or anything else. There will always have to be some kind of human input possibility for cars being driven in open environments. Closed environments, freeways maybe, or San Francisco in the middle of the night maybe, but open environments not.
I mean, you can imagine if you were ban human drivers, I think in a few decades you can actually have traffic systems which are completely automated with individualized vehicles. I think it's possible, but you have to ban human drivers, and you should also ban pedestrians and bicycles and so on, because they are the problem. They create complex non-ergodicity. And so if you could, I mean, some of the Asian cities I've been to, they look quite like, cities already now that are completely inhuman. And so you could basically create it if the AI system would only communicate with each other. But even then, the system, it's very, very demanding, because the problem of communicating agents is totally unsolved. And it is also a complex system problem. So even if you have many simple systems that should act in coordination, it's probably mathematically unsolvable. So even then you would have to have very strict rules of how the cars would move. And a lot of the complexity, one reason why AI is so overestimated is that in one's own life, one isn't aware at all of the complexity of what one is doing all the time. And if you speak of people who had a stroke and who are getting rehab, they are aware of it, how difficult the simple things that we have to do in our daily lives are, because they are now handicapped because they had the stroke, and then they have to relearn it. And suddenly they realize a bit how enormously complex it is. But we don't, when we are naively leading our lives, we don't see it. And that's, I think, another reason why people underestimate the complexity.
Yeah. And so as far as people underestimating or underestimating complexity, overestimating what we can know or what we can model, it takes me back because my background is in the social sciences, and you have these big theories in the social sciences. I don't know if you know, there's a guy named Peter Turchin who thinks he can model the course of war. So he'll say at ancient Rome, this happened, and then this generation was peaceful for this reason, and this generation had a collapse. And I've always thought that, I think I independently came to the conclusion that you guys did, that this stuff is bunk, that this stuff really doesn't explain much. And is that your feeling about these sort of social science models that try to model, macroeconomics, maybe wars, the course of history? Are these just sort of, kind of alchemy, a kind of pseudoscience?
I wouldn't call them pseudoscience, because why do we do humanities? Yeah, Barry and I differ a bit. I mean, we don't differ about why do we do philosophy, but about humanities. I think humanities are done to provide interpretations of our life, right? And so they are very important. And these interpretations can also be very useful, like in psychology, usage of psychology. So, but humanities usually can't explain causalities like physics can. Right. And that's because the systems they are dealing with are so super complex. So they can only interpret what's going on. I think these interpretations can be very, very useful for many, many purposes. I mean, look at Henry Kissinger. Why was Henry Kissinger such a successful power person, such a successful politician, and also advisor for politicians? I mean, he was incredible genius because he had a lot of political science and history and sociology education. So he could interpret what was going on really well. And that's a great capability, but that shouldn't be confounded or be taken as being the same as explaining, and let alone predicting. So that's, of course, completely impossible with the humanities.
And I wouldn't say that Kissinger was so successful because he had some model of the way the world works or about the way war works. On the contrary, he had Fingerspitzengefühl, that is to say,
intuition,
green finger.
Yeah.
Yeah. I think you're right. I mean, Kissinger is not the sort of he was a scholar of international relations, but not the kind of scholar they're producing today. Today, the scholar will tell you, 35% chance, democracy will collapse in the next 5 years.
Yes.
Something like that. Yeah, they do this, and I've always found this, ridiculous. I think
it's pathetic.
Yeah. So yeah, what would the final question, I guess, is what would a lot of smart people disagree with your ideas about the possibility of super intelligence coming from machines. What would cause you, say, in the next 10, 15 years, 20 years, whatever arbitrary time scale, to change your mind? What kind of development could tech companies or somebody produce that would make you say, okay, maybe super intelligence is possible?
Okay. It's very easy to say. If a mathematician, and great mathematicians have tried, could come up with mathematical models for complex systems that are holistic and convince me that they can deal with evolutionary change, with non-ergodicity, with behavior-relevant chaos, with context relatedness, force overlay, and so on. If mathematicians could come up with a new type of mathematics that could model this, I would say, bingo, we are going to get artificial intelligence. The point is that I believe that the structure of our brain, on which mathematics is built, right, and which is the grounding and the reason why we can do mathematics, is not made to do this. But if somebody can come up with mathematics that can deal with these phenomena, I would say now we are going to go to artificial intelligence.
And I would just add that I disagree with the premise of your question, because the more I follow the way in which leading AI people, I don't now mean the AI people who are hot on Twitter. I mean the leading AI technicians and theorists. Not many of them actually are convinced by the Singularity talk or by the idea that there will be artificial and general intelligence. So I'm thinking of somebody like Gary Lucas, who he's not completely on our side, but
Gary Marcus.
Marcus, he's not completely on our side, but he gets very close to the views that we defend. And he has exactly the same view about ChatGPT. He thinks it's a parlor game. So it's a nice toy that you can fiddle with, but it's going to be abandoned very soon because it's for
but
any use.
Doesn't Bostrom in his book, doesn't he have surveys of artificial intelligence researchers, and don't they say that in some normal, some not too far distant future?
Yes. So I think we would have to look at how prejudiced his choice of the people he surveyed might have been.
I think he has a biased selection, and it's easy to get a biased selection because most of the people. So you need to understand physics, thermodynamics, mathematics, theory of mathematics, theory of mind. I mean, there's a lot. Basically, you also need to understand quite a bit about human language because it is the highest expression of intelligence that we have. So you need to, or one of the highest. But if you see composing music and drawing works of art also, so these are ways of that all of this you need to understand. And I think that the people who predict the singularity are really, if you look at their writings, they just lack education. That's the problem. They lack education. If you're really well educated in a holistic sense, and know sciences and have thought through mathematics and physics, I know no mathematician or physicists, I mean, with the exception of people who haven't thought sufficiently, but who thought about the problem of AI and who are proponents. The loud proponents, actually have no clue. I think no matter how many neural networks they have engineered, they are unable to reflect what they are doing. And this is, by the way, very, very typical of scientists traditionally, that scientists are not very good at thinking philosophically about what they're doing. There are some exceptions, like Ernst Mach was a great exception, but there are not so many. Most of them can't reflect what they're doing, and that's why they predict the singularity.
Mm. So Jobst, I mean, you said that if someone developed a new mathematics, that's a very sort of theoretical and abstract. Is there something that like a machine can do X that would just blow you away and say that I would have never suspected this, and this sort of makes me rethink things? Is there something like the machine could do a podcast interview with you? Is there something it can do that?
Yeah, if a machine could pass, so the Turing test, we have a kind of described in the book and one of our papers, an enhanced version of the Turing test. And if the machine could pass the enhanced version of the Turing test, I would say, okay, now it's intelligent, but it won't. And this enhanced version is really not a 3-minute conversation via chat interface, but a real face-to-face conversation where the machine has to understand facial expression, the nuances of the voice, and react appropriately on various topics, and actually display intersubjectivity. So now if the machine could in such a conversation display intersubjectivity, like is shown in the movie Ex Machina, where the machine, which is fictional, where the machine displays intersubjectivity, then I would believe now we have artificial intelligence.
So the point of the original Turing test is that you could fool a human being, and your extensive Turing test is beyond that, right? It's not just you fool a human being. There has to be something more. But when you say it shows intersubjectivity, that seems itself to be sort of subjective. Is there an objective test that everyone would agree on?
Subjectivity can be tested for. So, I mean, it would, but Barry, what would you say on this?
So it's useful to describe the enhanced Turing test. So it's based upon the Stasi in East Germany. So the Stasi interrogator would take 4 hours to find out whether somebody was telling the truth. And the way you do it is you go through their life history and you test their the strength of their emotional responses when they're asked to describe their mother and their relation to their mother and the people down the street who were noisy and so on. And you watch the emotional reactions. You have to gauge them from the speech of the machine. That was the way the Stasi worked. And that would mean that every computer would have to have a life history, a cover story, which would be able to answer the kinds of questions that humans answer. And then a cover story for a human is very difficult to replicate if it's not your life, because you have to replicate all the emotions which go together with having such and such a mother or brother, or having a close relative die young and so on. And that's hard to
that's
requiring it to have a human level intelligence. So what if we just so the Turing test, so I guess would the test be just it's a Turing test. The objective data you're looking for is if somebody is fooled by them, they're indistinguishable from a real human, right? Is that the data? And it just has to be longer. It's just longer,
but also much more multidimensional. So exactly in the way that Stasi interrogators. They want to know everything about you, and they want to see how you react. And if you react in an authentic way, then that is a good clue that you're telling the truth. And if you do that over 4 hours, you get a really good measure of whether you're telling the truth. And that measure would be equally useful as a measure of
but to test for animal but your question is very good. So you could also figure out such a test for animal intelligence, and this you would have to do by setting a machine in an open world scenario and letting it do tasks in the open world scenario. And there's this robotics specialist whom we also quote in the book. At the moment, I fail to remember his name. In chapter 3 and in chapter 13, we quote him. Barry, maybe you can quickly look him up while I'm talking.
I'm on holiday. I don't have any books.
I could look him up, but it doesn't matter. He describes that animal intelligence should be tested by letting animals really do complex tasks in open environments where unexpected events can happen, like it happens, in a forest or in a jungle. And then I would say if the machine would perform this, it would also, I would see it as, and it should also be able to collaborate in a flock with other animals or in a herd. And so this is a type of to test an animal. And I think that would also convince me that we have achieved animal intelligence, which would be great, because then we could, delegate a lot of work to this intelligence. But we are not anywhere near this at all.
Not even for insects.
Okay. Well, yeah, I'm glad we have a a sort of an empirical test that we have that benchmark. The book is sort of, overwhelming, sort of these arguments, these debates are sort of overwhelming, even for a very, even for very smart people. And, Jobst, I think, talked about, you have to know something about, philosophy, something about biology, something about chaos theory. I guess, I'll end by asking, is there, if someone just wants to sort of look into, what is for you the most convincing, is sort of the most important thing to understand besides read your book? If I just have the time to look into one or two things to really to get the best, the best version of the argument of why machines will take over the world, how would you give any advice as sort of, either specific readings or sort of what fields to look into?
So if you want to understand the limitations of mathematical models in nature, and understand it by one of the best physicists of the 20th century, you can read volumes 1 and 2 of Richard Feynman's lectures in physics. And because even in those two, these are only covering classical physics. Quantum mechanics is only at the end of volume 2 and then in volume 3. There's a bit of quantum mechanics in volumes 1 and 2, but very little. So it's without quantum mechanics and without general theory of relativity, which is inaccessible for the non-mathematician. But the mathematics required to understand volumes 1 and 2 is not, it's undergraduate mathematics of the simpler kind. It's possible to grasp it. Feynman even re-explains the mathematics for non-mathematicians in the book and so on. And so these books give you a very good impression of how one of the 2 or 3 greatest physicists of post-World War II, so the first generation after the very greatest, after Bohr and Einstein, how he sees the limitations of physics. And it's so clear on almost every chapter, the way he makes a difference between the real nature and the kind of models that physicists create. It's so modest and beautiful. So if you understand this, you also understand the basic argument of our book.
And at the opposite extreme, people should read chapter 12, which is about the various ways in which people hanker after life in a superhuman universe. So why they read science fiction and why Nick Bostrom creates science fiction in answer to this need. The science fiction being the idea, for instance, that we could evolve superintelligence by selective mating, raising the power of human IQ by exactly 43.2 points, he said.
Rodney Brooks, by the way, is the name of this great robotics specialist.
Yeah.
What's his name?
Rodney Brooks. He's an American robotics specialist.
Still alive.
What? He's still alive, and
yeah.
he has a very close view of intelligence that we have. And he has developed it just from thinking about how to build intelligent insects. And I really like him a lot because he has basically defined the AI test for animals. He's really good.
Okay, great. Okay, yeah, we'll put the links to all of that. Okay. Barry, Jobst, thank you. This has been a great conversation. Thank you very much for joining.
Thank you.
Thanks for taking the time. It was a pleasure talking to you.